This is number 58, where you have to use the double angle formula for the sine when the sine of x equals 5/13 is given. Also, the secant of x is less than 0. So first of all, make yourself a visual to see A, in which quadrant you are in, and then kind of draw a triangle and label everything and see what's missing. Okay, we have a positive sign and we have a secant that is less than 0, meaning negative. Remember, all students take calculus. So the sign is either positive in quadrant 1 or in quadrant 2. In quadrant 1, all other trig functions are positive as well. So it has to be quadrant 2 when the secant is less than 0, meaning negative. And that's the case. So let's just make a little triangle. Here's our angle, x in this case. We have 5 opposite over hypotenuse 13, and this is what's given. So let's write the formula, the double angle formula for the sine of 2x down, which is 2 times sine of x cosine of x. Okay, so we have the sine of x. What we don't have is the cosine of x. So let's find the adjacent side. The adjacent side, because it is a right triangle, is the square root of 13 squared hypotenuse minus 5 squared. 169 minus 25 is 144, which is equal to 12. But in this case, because we're in quadrant 2, it's actually negative 12, and that's why the cosine is negative. Okay, so let's plug it all in. 2 times sine, which was 5 over 13, times negative cosine, which is adjacent, negative 12 over hypotenuse 13. Don't forget that 2 is over 1. So you just multiply your numerators. 2 times 5 is 10, times negative 12 is a negative 120 over 169. There you go. That's it. Okay, let's take a look at number 62, where we have to simplify. The cosine of 2x minus 1 is 1 minus secant squared. Let's actually look at 1 minus secant squared. That is one of our Pythagorean identities. 1 minus secant squared is negative tangent squared of x. So now let's take a look at using this double angle formula for the cosine here. We have several different ones. If I look at the answers, the cosine of 2x is either cosine squared x minus sine squared of x, or if I change it in terms of sine, so that would be 1 minus 2 sine squared of x. So let me use that one. We have 1 minus 2 sine squared x minus 1 from this one right here. So you can see that I cancel out the ones, which leaves me with a negative. Let me write out negative sine squared of x over negative tangent squared of x. If we change the tangent to sine and cosine, negative 2 sine squared of x all over, actually, let's just, a negative divided by a negative is a positive, so we don't have to worry about the sign. Divided by sine squared x over cosine squared x. So this just means here that we have to multiply by the reciprocal. times cosine squared x over sine squared x. And this can be written over 1. We can see that the sine squared, they reduce, and we are left with 2 cosine squared x. That is our final answer. And I do believe, let's just take a look at it again. That was A. There you go. Okay, let's do one more. Okay, the next problem is number 64. We want to find all the solutions in the interval from 0 to 2 pi. 0 included, 2 pi is not included, for the square root of 3 secant. Secant 3x plus 2. Okay, let's isolate and get the secant of 3x by itself. We're subtracting 2 and then we divide by the square root of 3. So the secant of 3x is equal to negative 2 square root of 3. Now, it's easier to work with the cosine because cosine is the reciprocal of the secant. So instead of saying secant, I can also rewrite that with the reciprocal, and that gives me the, well, let me actually rewrite it here. So 1 over cosine of 3x is equal to negative 2 square root of 3. So if I multiply everything by the cosine of 3x, then I take the reciprocal. So really what I'm solving is 3x equals negative square root of 3 over 2. Okay, so now first step we're doing is we're disregarding this 3x. We're finding the angles for which the cosine is negative 3 over 2. Well, the cosine is negative square root of 3 over 2 in quadrant 2 and in quadrant 3. Okay, and if you go by my drawings here, let's draw a special triangle with 60 and 30 degrees. We have 1, 2 square root of 3. So the square root of 3 over 2 cosine would be 30 degrees or pi over 6. So now we're writing all the angles down for which the cosine is negative square root of 3 over 2, but we're writing it as 3x equals, what did I say, pi over 6. In quadrant 2, that would be 5 pi over 6. So that's one of the possible answers. And, well, this is one of the possible equations. And the other one is 3x equals, in quadrant 3, 7 pi over 6. Now we have to divide by 3 both sides here, and when we divide by 3, that is the same as multiplying by 1/3, so x is equal to 5 pi over 18, and x here is equal to 7 pi over 18. Okay, so now we gotta find all the angles that are between 0 and 2 pi. Since our denominator is 18, 2 times 18 is 36, so we're really looking at 36 pi over 18 as being our maximum value. We don't want to go past. We also have to look at the period. The period in this case, how do we find it? 2 pi over b, and b is 3. So the period is 2 pi over 3. So what we have to do now is multiply by 2n pi over, add by 2n pi over 3 to find all the values, and we stop at 36 pi over 18. But to make this easy on us, we're going to change the period into denominator of 18. So you're going to multiply by 6 here. So that gives us 12 pi over 18. Okay, so off we go. Let's find the next angle here. We're going to add 12 pi over 18. So 5 pi over 18 plus 12 pi over 18 is, let me just write them here. I can write below. 17 pi over 18. So that's your next angle. We're going to add 12 pi over 18 here, and that would be 19 pi over 18. Okay. We still haven't gotten near 36 pi over 18, so now we're going to do it again. We're going to add 12 pi over 18 to the 17 pi over 18, which is 29 pi over 18. We're going to do it here one more time, plus 12 pi over 18, and that gives me 19 plus 12 is 31 pi over 18. Now if I were to add another period to it, my values would be larger than 36 pi over 18, so I can't do that. So the solution here is, in purple, let me list them all. We started with 5 pi over 18. Then we had 7 pi over 18. The next one was 17 pi over 18. We got 19 pi over 18, and then in green, 29 pi over 18, and the last one, 31 pi over 18. Wow, that's a great problem. Here you go. That's solving equations with multiple angles. I'm going to stop that right here.